Good morning. Welcome to another virtual ECOC. I am excited to be able to present to you today about Coherent moving toward the edge and the transformation of Coherent in the way it's used in order to realize a better power, a better cost structure, and a better architectural structure for the edge networks going forward. So I very much appreciate your time as we get into this topic. The advent of 5G in a network has started to be and will truly be just transformational in a network in so many ways. First, the obvious ones, the bandwidths go up, right? The peak data rate going up to about 2.5 gigabits. The latencies are decreased in the application space, and that allows for the movement of the data centers, the mobile edge compute, or even the cloud-based data centers to move out towards the edge. That is going to create a major restructuring in the overall network and how the functionality of the network, the revenue streams of the network, the content of the network are distributed. And the drive towards the edge is going to be a dramatic, one of the most dramatic changes in the network going forward. The number of devices, which is going to rapidly move to 1 million devices per square kilometer, looking at 43 billion devices by 2023, and we expect that to move to 1 trillion devices. Huge ramifications on the connectivities of the network, not to mention ramifications also in the security of the network. As we look at the technologies and the needs of what we need in technology, we need to see 1 to 2 orders of magnitude of bandwidth increase. Again, the latency reduction and the connectivity density. And all that's going to ultimately apply to the reconfigurable nature of this network. The ability to create an architectural tools that allow you to establish different types and different capabilities of edge networks and be able to configure them remotely. Because at this level and this bandwidth and this number of devices and this number of locations, you cannot manage the network as it has been doing in the past. The truck roll count can't continue to scale. The truck roll count has to go down as the bandwidth continues to go up. Okay, so what's that look like from a network? Well, a number of things are happening in the architecture of the network. One, the number of cell towers is going up dramatically. And the cell towers are going to be pushing much of their compute functions likely from the actual tower location, in many cases, not in all, in many cases, and they're going to stick it further up into the network where you can aggregate multiple cell towers. So the cell tower count is increasing and the architectural aggregation. The problem is that the current aggregation locations, the central offices or equivalent, well, they're full. They're full of transmission gear, they're full of switching gear, they're full of aggregation gear at those locations. And so there's not a lot of power to go around to bring in the edge compute functionality. So I need something that's going to break that paradigm, simplify the network, break the constraints of the networking equipment in order to bring in revenue generating equipment in the form of cloud and compute infrastructures. And I'm going to need to reconfigure those locations routinely, depending on what the bandwidth demand, and that can't be done by reconfiguring via human truck rolls. That has to be done in a software configurable and ultimately in an automated fashion from that. Point-to-point connectivity, standard technologies will be a burden in that. Space, complexity, and connectivity are key to the next generation networks, and that will sit and rely heavily on a redefinition of coherent technologies. Coherent technologies were developed with a original concept of how do I get more spectral efficiency out of my fiber. But what's come along with it now is the ability to create flexible bandwidth channels within my coherent transceivers, and that will drive coherent all the way to the edge of the network as the utilization of that. So I want to talk very briefly. Current aggregation networks rely on time division multiplexing to aggregate the information. In order to execute time division multiplexing, I need to convert those signals from optics to electronics, and then I use electronic switches or muxes to serialize the information, combine that information at a higher speed output. As the chunks of information increase, it is far more efficient to move from a time division multiplex technology basis to a frequency division multiplexing. And frequency division multiplexing, I can allocate frequency channels or bandwidth to a particular application or a particular end user. And by doing so, all of a sudden the aggregation functionality is done in the fiber itself. It is by aggregating multiple frequency channels from end locations that radically reduces the cost and complexity of the network as the aggregation speeds go up. Originally, in coherent transceivers, the concept of frequency division multiplex channels, it was derived by the use of subcarriers for enhancing the spectral efficiency of subsea networks. We've been deploying this in Infinera gear in our long haul networks for a number of years now, in order to maximize the capacity of the fiber, maximize the reach of any given signal capacity. But if I take that same technology and I reapply it as applied towards edge networks, to the aggregation networks, then I can see what I can do is within the same architectural concepts, I can use the DSP to define independent frequency channels, and they are truly independent. And I just have to put a number of those frequency channels inside of a wide bandwidth optical transceiver. The case we'll talk about specifically is this 400 gigabit transceiver, which has a frequency bandwidth of roughly 64 gigahertz and a 16 QAM configuration. And we can chop that 64 gigahertz up into 16 4 gigahertz, 4 gigabaud signals, or more appropriately 16 25 gigabit independent frequency channels. And then the distribution of these 25 gigabit frequency channels can be moved via the management plane connectivity to any end locations, and thus make a completely reconfigurable network in the edge application space. So let's go back and talk about that for a second. I've got the comparative slides here. Today's network is built entirely with the use of point optics and point-to-point applications. And point-to-point applications, what we have is I've got low-speed devices that sit within my edge elements, and I want to aggregate those to a high-speed port somewhere up towards my hub. So I put in an intermediate aggregation layer, and I use that box to use time division multiplexing to take these low-speed interfaces and aggregate them into a high-speed interface. Alternatively, with Coherent, if we use the DSP to create independent frequency channels, then what I find is I can take a low-speed transceiver, couple and lock the hub and the edge devices in the frequency domain so that I can aggregate independent different frequency channels from the edge into a single transceiver at the hub. And so doing, you eliminate 50% of the transceivers, you eliminate an aggregation layer, and therefore I've eliminated space, power, and cost, and I've improved the reliability and latency of the network. That simple transformation saves, again, 50% of the transceivers, eliminates the aggregation devices. It makes my router more efficient because the port, I can operate with high capacity port densities. I eliminate the truck rolls because I'm now in a broadcast network, and I can redistribute the use or access to each one of these frequency channels strictly through the management plane connectivity. And that leads to savings that are on the order of about 70% network savings within the system. Truly breakthrough from that. So we call this XOR Optics because it is effectively moving a certain portion of the switching infrastructure into the optic, the aggregation switching, that is. But that same optic can operate in point-to-point mode. So today's networks, which are designed in point-to-point mode, can take these same optics, plug them in, and have a complete solve the exact same problem of ZR plus. And so taking XR optics, operating them in ZR plus mode allows for that same point-to-point configuration. In so doing, all of the reach, all of the economics, all of the interplay between two 400 gig transceivers is the same. However, it is software configurable so that if I want to evolve that or take advantage of that, of either in the future where I want to have my 400 gig optic talk to an 800 gig optic, or if I want to create aggregation on-ramps at 100 gig incrementals or any multiple of 25 gig incremental. So I can have this one optic with a unique DSP that is software configurable to achieve both point-to-point as well as point-to-multipoint, and therefore satisfy all of my applications. Matter of fact, the software can allocate that bandwidth regardless of whether I'm operating on a single fiber and I need bidirectional frequency channels, or whether I'm on a multi-fiber or dual fiber set of access technologies. Ultimately, it creates the first time within optics a true intergenerational networking between my low-speed ports and my high-speed ports and my future generation ports. It leads to a highly automated allocation of bandwidth between my different nodal nodes within the network. It creates complete management. It replaces the current layer 0 management infrastructure and builds that complete management into the pluggable element. So you don't have to compromise and rely on your router to manage your layer 0 network. You can still have an independent management and reporting of the layer 0 network, even though the plug may sit within a layer 2 or a layer 3 device. Streaming telemetry of the status of any of the transceivers, the characteristics that you want to track on the health of the network, et cetera. Fully compatible with going to high performance QSFP DD packages as well as CFP2 packages, and in the future in the QSFP 28 type of packages. They have integrated optical OSAs, operate in single fiber and dual fiber configuration. And so you have this full, robust capability, and it all sits within the form factor of a QSFP DD transceiver. So what's that mean to the network? Once I now create this technologies that can go from low speed to high speed, I can start rethinking about this whole network. If I look at the current radio network, we have transceivers in our radio units, and I count the number of transceivers that data goes through by the time it gets to the regional data center. Well, it goes through 52 transceivers, and it goes through 26 network elements, and they are switches and routers, layer 1 devices, or transport devices. If I allow those transceivers to speak low speed to high speed connectivity, and I anticipate the movement towards virtualized routing functionality, well, then those 52 transceivers turn into 7, and those 26 elements turn into 4. A dramatic simplification of the network occurs because of that connectivity change. It is that connectivity change that now solves the problem that I'm having within my edge compute functionalities, in that I now have freed up space and power within my central office. I have radically simplified the connectivity between all of my end elements. And I've enabled the technology that allows for this 1 to 2 orders of magnitude of scaling of my edge compute location. And I can now set up from my current aggregation center or future aggregation compute centers a point-to-multipoint architecture utilizing the redistribution of frequency channels or reallocation of frequency channels in a software configurable fashion, make connections to all these elements, and manage the network without having to constantly go on truck rolls in order to upgrade the capacities of that system. But because it is now a broadcast network, it operates over very simple passive optical network elements, and I can use the management plane to allocate bandwidth, whether it's from the aggregation unit here, 25 gigabits to one of the cell towers, or I can upgrade that strictly through my software management, where I can, here I've increased 25 to 50 gigs here, 25 to 75 gigs in my central tower unit, and whether it is in a reallocation of bandwidth of doing daytime and nighttime, or event-driven, I can use the redistribution of these bandwidths to different locations in that process without, so efficiently utilizing the bandwidth, minimizing the cost and power within the network. All this by the transformation to point-to-multipoint optical transceivers. Let's see. The management system of the optical infrastructure all sits within these modules. As a result, you can directly connect to the layer 0 functionality in the transceivers to be able to use your diagnostic tools for troubleshooting. You can identify your fault. You can create automatic operations in order to manage the system and utilize either the in-band per frequency channel connectivity or out-of-band connectivity, which is accommodated for within the structure of XOR Optics. It results in a faster turn-up for the system. Net, lower CapEx. You can see numbers that are in the 50 to 70% savings of the network. Lower OpEx. You can see numbers that are equally comparable in the savings of the amount of equipment necessary in that. Dynamic capacity allocation by assigning these 25 gig subcarriers to any one of my edge elements. I can manage it remotely, and I can use my layer 0 infrastructure to report directly on the health of my layer 0 network and that. I can allocate bandwidth either in a 2-fiber configuration or a bidirectional single fiber configuration. And I can future-proof it, which means in the future, when I have 800 gig plugs, I can connect my 400 gig plug directly to an 800 gig plug. And I don't have to now upgrade both ends of my fiber. I only need to upgrade one end of my fiber. So the last thing that's critically important is creating the ecosystem around XOR Optics. So in June, we launched on the formation of OpenXR Forum. And it's a forum that has drawn carriers together worldwide in order to establish the protocols that you allow them the integration of XR into their systems. Much of the early time has been on the management systems and the ability to transparently connect through the management system of your host box directly to the pluggable transceiver. And in doing so, preserve, even in point-to-point networks, you can preserve the layer 0 management, even though I sit within a layer 2 or layer 3 device. That open management system now creates an environment where I can create point-to-point, point-to-multipoint, multi-layered point-to-multipoint, and the reallocation of bandwidth. This forum is the formation of an MSA partnerships. The initial members are the end users, the Verizons, the British Telecom, Lumen, Virgin Media, Windstream, Colt, and a number of others that will be joining shortly. And it will ultimately draw in the equipment integrators as well as other component manufacturers. We believe that this forum will create the first truly enabling fully standardization of coherent optical transceivers, and in a form that allows for a dramatic cost and power reduction of the network.
Thanks, Dave, for the great presentation. My name is Fadi Massoud. I'm a director in solutions marketing at Infinera, focusing on XOR Optics. Dave, I have a couple of questions for you. First is a great presentation, a lot of great info and insights on XOR Optics. But you mentioned it. XOR Optics is not a walk in the park. It's a place where no one has gone before. Can you please shed some light on the technical challenges that Infinera has to overcome to build the world's first point-to-multipoint coherent optics?
Yeah, well, great question, Fadi. The XOR Optics is encompassing so much of the technology that have been proven, right? So the first big potential technical barrier, which is the formation of digitally generated subcarriers, well, that's actually been in production for almost a half a dozen years now, for that in the form of our long haul DSPs. And so the ability to make the subcarriers or the frequency channels is pretty straightforward. So the next piece is, well, can you make it into a DSP? Can you get it into a CFP2 or a QSFP DD package? And certainly all the modeling fully supports the powers that we would expect to get from that. So I don't foresee any significant technical barrier in integrating in the use of subcarriers in these modules and the ability to independently manage them in that module. The biggest transformation that will go on is that XR and the point-to-point mode is very straightforward. It operates just like ZR Plus in point-to-point mode. XR and point-to-multipoint mode creates opportunities for the network, but it also has a little bit different management style than of the optical element than ZR Plus. That will ultimately be rate limiting. And the way the carriers utilize it is because they're going to want to modify and take advantage of those features in their management system. As far as I can tell, they're fully committed to that, but that's actually the technical, it's not a technical barrier, it's a technical evolution of how to exercise the feature sets within XR. Other than that, it's really very straightforward to pull together this technology.
Great, thanks, Dave. And I mean, you mentioned ZR Plus, but I have another question on that ZR Plus. I mean, if you look at all types of articles and webinars and what have you, ZR Plus are expected to kind of change the network economics. How do you see XOR Optics and their system level features? You mentioned those embedded system level features transform this market, especially when it comes down to point-to-point connections.
Yeah. So the ability to software reconfigure the use case for XR, either from a ZR Plus mode of operation where it's operating point to point, or to where I've got a multiple endpoints, connected through one pluggable, and I can use that software configuration to redistribute the bandwidth around. That's a really big deal, and that is a even bigger deal, as we talked about in the talk, when I start thinking about the intersection of that capability with the migration to edge compute. And the integration of edge compute into your high density access networks like 5G in that process. And that it is bringing those two elements together that really make a difference for the application, as you can operate it in point-to-point mode, operate it in point-to-multipoint, and seamlessly move that bandwidth down and utilize that bandwidth as best fits your application.
Great. And Dave, you mentioned 5G, you mentioned distributed compute. From all the interactions you've had with customers around the globe, how do you see XOR Optics intercepting time-wise those new technologies?
Yeah, so we'll start getting product out to them in next year, 22. The customers seem to be reasonably well aligned with that. They always wanted earlier, which is good news. So I think we can get that on out into the marketplace. There's certainly going to be some ZR Plus product out there earlier than this. I think actually the implementation into the QSFP DD packages, we're pretty much right on target with that product coming to market and the timing of that. But in the end, ultimately, it has to do with the value you create. If I was coming out with a product which was identical in capability as something that's been on the market for 2 years, yeah, that's a pretty tough sell. But we're bringing out a product, an XR is a capability that really just drives huge cost savings and architectural advantages to the network. They need it as soon as they can get hands on, because the network, they want to intersect the network transformations with this type of technology. In that regard, I think we're in a good spot, and that good spot means the customers want it now. We'll deliver it next year, and we'll the value it creates justifies working with us to get that implemented.
Great. And Dave, last question, if I may. The OpenXR Forum includes an impressive list of some of the world's major service providers. This by itself is a testimony of how the industry sees the potential of XOR Optics transforming the network. Can you please shed some light on the goals and the focus areas that the forum is currently working on?
Sure. OpenXR Forum is a collection of end users, and ultimately will include system integrators and component suppliers. Right now, the end users are focused on coming in with a common management plane architecture, so that when we plug this in any box, whether it's a transport box or whether it's any other switch and router box, that they have an easy access to the management plane of the module, right? Because what XOR has built into it is all of the capabilities of a standalone transport box, but it's within the module, so they can manage their network, they can manage their layer 0 network or their optical layer network the same way they always have, and they don't have to worry about the use of the routing management system to report on and figure out what to do with the optical layer. That's a big deal for them, and that's where they're focusing their initial efforts right now, is to make sure that the management plane can connect directly to the end user's infrastructure, and they can then come on down and directly manage and communicate with the optical layer of the pluggables.
Great. Thanks, Dave, for your insights. Thanks, everyone, for attending, and have a great day. Enjoy the rest of the day.
Thanks, Fadi. You guys have a good ECOC. Thank you.
Cheers.